For more than 70 years, we thought our solar system map was complete, a familiar and well-ordered collection, 9 worlds, orbiting a single star. But in the depths of cold darkness, billions of kilometers beyond the most distant known planet, lurked a specter. A tiny speck of light, slowly, almost imperceptibly, drifted through photograph after photograph that astronomers had forgotten, unnoticed, and undiscovered for years. Its discovery didn't just add a 10th name to the list of planets orbiting our Sun. It created an identity crisis for the solar system itself, forcing astronomers to bitterly debate the meaning of one of our most fundamental words and, in turn, redrawing our solar system map forever. This is the story of the world that, by its very name, had sown the seeds of controversy in the scientific community. I'm McColgan, and you're looking at Astrum. Join me today as we journey to the chaotic outer reaches of our solar system to meet Eris, a world that has waged war over the meaning of a single word: planet. The story of Eris began not with a lucky glimpse through a telescope, but with an effort to compile a comprehensive catalog of the most distant objects from the Sun. At the Palomar Observatory in California, a team of astronomers, Mike Brown, Chad Trujillo, and David Rabinowitz, embarked on a systematic survey of the outer reaches of our solar system, searching for signs of objects orbiting beyond Neptune, called trans-Neptunian objects, or TNOs. The team used the 1.2-meter Samuel Oskin telescope to take images of a wide field of sky, running them through automated image-searching software that identified objects moving at specific speeds. And their search was already proving fruitful. With newfound worlds like Quasar, Orcus, and Sedna, they were slowly populating this dark, distant realm. But the team was hoping to find something bigger. There must be a 10th planet, Mike Brown later wrote. The possibility that Pluto would be a unique planetary oddity at the edge of the solar system seemed absurd to me. He began re-examining some old datasets that his software had ignored. Then, after months of re-examination, on January 5, 2005, Brown clicked through a series of 3 images taken on October 21, 2003, and there, in the images, was a single faint dot of light, moving at glacial speed against a still starscape. Brown knew immediately that this was something important. It was bright, meaning it was either large or highly reflective, and it was moving much slower than anything found before, meaning it was incredibly distant. His first thought was, "I've found a planet." The team began tracking the object, tentatively named 2003 UB313, to determine its orbit and size. They planned to keep their discovery a secret until they could complete more observations, but the competitive world of planetary science intervened. On July 27, 2005, another team controversially announced the discovery of another large TNO, Haumea, after accessing the Brown team's public observation log. Once again, to prevent anyone from making the announcement first, the Brown team was forced to go public. On July 29, they announced the discovery of not one, but 2 major objects in the outer solar system, Haumea, and this new object, which would eventually be called Eris. The secret was out, and the solar system would never be the same again. In Greek mythology, Eris is the goddess of discord, a mischievous deity who, when neglected at a wedding, threw a golden apple inscribed to the fairest among the goddesses, sparking a feud that led directly to the Trojan War. In 2005, the discovery of the cosmic object that would bear her name was the modern equivalent of that golden apple thrown into the halls of astronomy. It sparked a scientific battle over the definition of a planet. The problem was simple, yet profound. Initial estimates suggested that Eris was larger than Pluto, and later calculations based on the orbits of its moons showed that it was 27% more massive. If Pluto were a planet, then Eris, its more massive twin, would surely be a planet too. And if Eris were a planet, what about the other large TNOs that had recently been discovered, such as Makemake, Haumea, and Sedna? Where to draw the line? This discovery created an inevitable logical crisis. As Mike Brown put it, we either have to add a new planet or subtract one. The International Astronomical Union, IAU, the global body responsible for naming the universe, was forced to take action. At its 26th General Assembly in Prague in August 2006, for the first time in history, the question, "What is a planet?" was formally debated and voted on. The debate was lively and exposed a deep rift within the astronomical community, essentially dividing them into two camps. On one side were those who favored a geophysical definition. They argued that a planet should be defined by its intrinsic properties. If an object is so massive that its own gravity, if a body could overcome its gravitational pull and pull itself into a nearly spherical shape, a state known as hydrostatic equilibrium, it should still be called a planet. Under this simple definition, Pluto, Eris, the Dwarf planet series, and possibly dozens of other objects would have become planets. On the other hand, there were those who favored a dynamical definition. They argued that a planet's identity was tied not only to its physical state, but also to its gravitational influence on its surroundings. A true planet, they claimed, must be the dominant gravitational player in its orbital region. In the words of the final proposal, it must clear the area around its orbit. The voting process itself was fraught with controversy. The final vote was taken on the last day of the 10-day conference, by which time most of the 2,500 participants had already gone home. Only 424 astronomers were present to cast their votes, a tiny fraction of the global astronomical community. When the votes were counted, the kinematic definition prevailed. The IAU passed Proposal 5A, which established a three-part definition for a planet in our solar system. It must A. be in orbit around the Sun, B. be in hydrostatic equilibrium, and C. have cleared its surroundings. Pluto, sharing its orbital space with Neptune and many other Kuiper Belt objects, failed the third criterion. A new category was created, Dwarf Planet, for objects that met the first two criteria, but not the third. Importantly, a follow-up proposal that would have made Dwarf Planet a subcategory of planet was rejected. Instead, the IAU declared that planets and dwarf planets were two separate classes of objects. In an instant, the solar system was officially limited to just 8 planets. Critics were quick to point out the flaws in this definition. The phrase "cleared the surrounding area" was vague. And the first criterion, in orbit around the Sun, applied only to our solar system and ignored the thousands of exoplanets we now know of. It was not a universal, elegant principle, but rather a reactive, controversial, and local solution. After the debate was settled, at least formally, the Discovery team had the honor of naming their troubled world. They chose Eris, a name that seemed perfect to Mike Brown for the object that had plunged astronomy into such controversy. The name was officially adopted in September 2006, marking the distant world's legacy as the cosmic apple of discord. If Pluto could think, it would undoubtedly feel disappointed that it was no longer a planet. But with change came many winners. For example, Ceres, previously considered an asteroid, was able to take its place in the new ranks of dwarf planets in 2006. After its discovery, established it as a cosmic disruptor. It's time to travel to Eris and understand the nature of this rebellious world. Eris does not reside in the relatively stable, disk-like Kuiper Belt, which is home to Pluto and many other icy objects. Rather, it belongs to a more chaotic and wild region called the scattered disk. Scattered disks are large, scattered uninhabited halos of icy objects with extreme orbits. They are outliers of the solar system. Objects that likely formed near the Sun, but were scattered into their current paths by Neptune's gravity billions of years ago, when Neptune shifted into its current orbit. Eris's orbit is not a circle as you know it, but a large ellipse that takes it 557 Earth years to complete. At its closest point, or aphelion, Eris comes within about 38 astronomical units (O) of the Sun, roughly the same distance as Pluto's average orbital distance. But at its farthest point, or aphelion, it travels as far as 98 astronomical units, about 15 billion kilometers. That's about 3 times the distance Pluto currently is from the Sun. Eris's orbit is also inclined at a steep bay 44 degrees to the ecliptic, the plane on which the major planets move. This means Eris spends its 557 Earth-year-long year soaring far above and plunging far below the rest of the solar system. For years, Eris was thought to be Pluto's larger twin. But in 2010, astronomers had the opportunity to measure Eris with incredible precision. Eris passed directly in front of a distant star, an event known as a stellar occultation. By timing how long the star's light was blocked from different locations on Earth, they could calculate its size with great precision. The result was a surprise. At 2,326 kilometers in diameter, Eris was almost exactly the same size as Pluto, and in fact, slightly smaller. This revealed one of the most important differences between the two worlds. With 27% more mass than Pluto packed into a slightly smaller volume, Eris must be significantly denser. Scientists calculated its density to be 2.43 grams per cubic centimeter, significantly higher than Pluto's 1.85 grams cubic centimeter. This suggests a different internal composition. While Pluto is thought to be a roughly 70 to 30 mix of rock and ice, Eris must be composed primarily of rock, with only a relatively thin layer of ice on top, a frozen shell containing a rocky core. That shell is also one of the brightest surfaces in the solar system. Eris has an albedo reflectivity of 0.99, meaning it reflects 99% of the sunlight it receives. This dazzling brightness is likely due to a phenomenon called atmospheric fallout. Like Pluto, Eris has an atmosphere made up primarily of nitrogen and methane ices that have turned to gas. But as its extreme orbit takes it into the deep cold of its nebula, this atmosphere solidifies and falls to the surface as a fresh, bright layer of snow or frost. As Eris begins its 208-year journey toward the Sun, this snow will warm up and be expelled, turning back into gas and renewing the atmosphere, only to freeze again centuries later. More recently, observations by the James Webb Space Telescope have added another layer of complexity. Analysis of different isotopes of methane on Eris's surface suggests that they were likely produced by geothermal activity, hinting at unexpected thermal processes deep within its rocky core. This distant, frozen world may have at least once had a warm heart. The key to unlocking Eris's secrets and the final piece of evidence that will seal Pluto's fate came in September 2005. WM. Using the Keck Telescope S Advanced Adaptive Optics System, a technology that corrects for the blurring effects of Earth's atmosphere to produce space telescope quality images, Mike Brown and his team identified a faint companion orbiting Eris. It had a moon that changed everything. While an object's size can be inferred from its brightness, its mass can only be determined with certainty by observing its gravitational pull on another object, a natural satellite. For example, by carefully tracking the moon's nearly circular 16-day orbit, the team was able to calculate Eris' mass with high precision by applying Kepler's laws of planetary motion. This calculation proved conclusively that Eris is more massive than Pluto, turning the planet debate from an academic exercise to a pressing necessity. The moon itself contrasts sharply with its parent object. Although only 25% of Eris' diameter, this moon is one of the largest moons of any dwarf planet, second only to Pluto's moon Charon, and larger than Saturn's Enceladus or Mimas. It is also tidally locked to Eris, but the amount of its mass that makes Eris wobble in its position is much less than would normally be expected for tidal locking. This means that Eris itself dissipates energy much more easily than we first thought. And, while Eris is bright white, its moon is incredibly dark, described as darker than coal. This suggests a very different surface composition. Lacking the bright snow that covers Eris, the leading hypothesis for the moon's origin is a giant impact, much like the formation of Earth's moon. Early in the history of the solar system, a large object likely struck young Eris, throwing a cloud of debris into orbit that eventually coalesced to form a single satellite. This violent birth of volatile ice moved leaving a darker, more rocky object. Just as Eris was named after the goddess of discord, its moon was named after her mythical daughter, Dysnomia, the demonic spirit of lawlessness. The name is fitting for a moon born of chaos, orbiting a world that overturned the established laws of the solar system. In the years since the 2006 vote, Mike Brown has earned the nickname the Pluto Killer, but that misses the true legacy of his discovery. Finding Eris didn't kill Pluto. It revealed Pluto's true family, making our solar system bigger, more complex, and more interesting. For decades, we had a flawed model, 8 planets of a certain character, and then one strange outlier. By forcing this reclassification, Eris has given us a more accurate and coherent picture of our cosmic home. The inner 4 are rocky terrestrial planets. There are 4 gas and ice giants. And beyond them lies a vast third realm, a swarm of thousands of icy dwarf planets, a population of worlds we are only beginning to fathom. Eris and Pluto are the kings of this third realm, the largest and most prominent members of the trans-Neptunian population yet discovered. And Eris itself remains a profound mystery. It is the heaviest known object in our solar system yet to be visited by a spacecraft. While NASA's New Horizons mission has given us a breathtaking, intimate portrait of Pluto, Eris remains a distant point of light, its secrets held in its embrace across billions of kilometers of empty space. A proposed flyby mission would take an estimated 25 years just to reach its destination, a journey that would span generations. For the foreseeable future, the goddess of discord will keep her secrets to herself. His discovery resolved a great debate, but it opened a new chapter in our exploration of the solar system, reminding us that the most exciting discoveries are not those that provide definitive answers, but rather those that reveal how much remains to be explored.